Hello, everyone. Welcome to another coffee chat session of my YouTube channel, Data Science with Sam. Today, I have an interesting guest from insurance world who's going to talk about a topic that is something kind of related to data science and actuary, and I would say to the bigger picture, it's related to data, AI, and machine learning. So welcome, Stephen. Thanks for joining my coffee chat session. It is an honor talking to you today. So welcome to my session.
Thank you, Sam. It's good to speak with you.
Yeah. So just for my viewers' benefit, would you like to speak a little bit about yourself? Just like introduce yourself to see what you do and how you basically grow your passion towards actuaries, actual science, and data science as well.
Absolutely. So my name is, as you said, Stephen Mathys. I am a professional actuary, so I'm a member of the Society of Actuaries. I have worked for direct insurers and reinsurers. I've worked for software companies, and now I do work for a software company as well. My background has been in life insurance and annuities, and I've worked on pricing. I've worked on forecasting. I've worked on valuation, which is, calculating reserves every period of time. So I've seen a lot of the different actuarial aspects. And in fact, one of the things that I often liked about the actuarial work was it was very tangible. It was very clear to say, as we're creating a price for an insurance product, I know that what's going to happen afterwards when somebody either buys that insurance product and hopefully doesn't claim for it, but if they do claim for it, we know exactly what it's going to be. And that's from my background. I was a physics major in college, and that is a very tangible, very real and concrete subject. You can experiment with dropping balls and you can see how they fall at the same rate regardless of their mass. And so I've always been a very tangible person. I'm always a curious person, and I've always liked to learn about more subjects. And so the actuarial profession attracted me because it was in that tangible way, and it was using a lot of math that I enjoy to do. And it was very clear that you could put something into a model and you could get an answer back out, and you could put the same thing back into the model, you could get the same thing back out. The numbers really don't lie. And that's really why I've stayed with the profession for quite a long time.
Thanks, Stephen. Thanks for the great introduction. And I totally, kind of understand your point of view, and I can resonate that to my thought. And also, I do have a huge passion in physics when I was in the high school. And I do actually wanted to be an astrophysicist, but again, I didn't choose that route because of other reasons. But physics is kind of like, again, as I said, it's so many things we can put it into cause-effect relationship. We can measure the effect in the tangible manner. And that's where the mathematics or statistics come into picture, right? We can always derive a model or some sort of projection based on numbers, and numbers don't tell lie. So anyway, now I'm going to start with our first, I won't say it's a question. It's kind of like a first topic I would like to talk with you, because I wanted to, get your feedback on that. And that is something like when it comes to data science or even actual science or any sort of like insurance related work or any other industry, when you do some analysis, it's all about storytelling, right? It's all about how you're going to narrate your story so that your viewers or customers would understand what you're trying to derive from that story. But so many times we kind of just tend to shift from that bigger picture, that like the term is so what, so why we're doing this, and why we should actually do this thing. And if we are going that way, then what will be the ripple effect? What will be the main outcome of it? But sometimes I feel like the data scientist, you can chime in whether the actuaries also have the same difficulty to share the bigger picture of that analysis or any predictive modeling. So I want to get your feedback on that, and how actuaries would usually tackle that kind of issue, and what you think in future, what a data scientist or even an actuary would think a little unorthodoxly, how they would narrate that, so our customers or even like anybody would will get the idea of that, what we're trying to mean by answering that question, that so what. So I wanted to get your feedback, perspective on that.
Yeah, that's a very big topic, and that's how you and I originally got introduced. My point was, many times people focus on the what because that's what's interesting to us, right? That's why we get interested in the physics or the data science or the actuarial world.
Right.
And yet everybody else that we're talking to is not a physicist or a data scientist or an actuary. They have their other agenda. They have their other things that they need to get finished in the week, the month, the quarter, the year. They have their own important parts. So, focusing only on the what feels very good to us. And it's also something that is very much generally in our control. And so we like it that way. And I'm not a data scientist, I am an actuary. And yet we use a lot of similar techniques and a lot of similar tools, a lot of similar ideas, in just applied them in different ways. So a lot of times actuaries apply them specifically to the domain of insurance, but we understand a lot of the data science techniques. Data scientists can probably use similar techniques, but might apply them in different domains, say marketing or operations research, et cetera. And I understand all of that. And in fact, even earlier on in my career, probably 15 or 18 years ago, we were doing data science techniques. We just didn't know to call it data science. We called it, machine learning a little bit. We called it some, regressive models, et cetera.
Artificial intelligence, correct.
Yeah, right. It's become a little more of it's become much more of a discipline, a well-defined discipline now, and I appreciate that. And actuaries and data scientists do work together. As you know, you work together with some of the people. I'm going to get a little bit off on a tangent. I don't think there's as much competition as some other people do. I think there needs to be a lot more collaboration. And again, that's where we need to come to this issue of so what? Like, what is the important part of what it is that you're doing? You can do an analysis. You can come up with your 7 different clusters of potential clients. Let's say if you're doing a marketing analysis, these are 7 different types of people that might buy an insurance policy. Well, sure, that's interesting and it's significant. You have a significant measurement for the data scientist. However, it's always imperative to take that next step and ask, so what are we going to do about this? Because if you have great insights, but you can't do anything with them, then what good is the insight? Sure, it's enjoyable for you as a professional to come up with that. Yes, look, I really think that was very fun and exciting to do. Unless you can translate that into something that's someone else can act upon.
Yeah, quantifiable measure or something. Like
quantifiable, some kind of measurement, some kind of action upon it. It's just going to sort of sit in a binder that is a great portfolio of what you've done. However, it's not really going to be moving anything forward anywhere else. This is important because, and as I said before, most of your audience for whatever you're producing is not data scientists. And for us, it's not actuaries. It's the marketing team. It's the finance team. It's the chief legal officer, perhaps. They want to know, have you been able to reduce some kind of a risk for us in this area? And they don't speak your same language either. So you really have to do the work. And that's where it takes some skill building to figure out how to think about what's important for that other audience. And if you can try to put yourself in their shoes and think about what's important for them, then you'll be able to take more steps towards figuring out the so what from all the data that you've analyzed and all the dashboards that you've created and the interesting visualizations that you've come up with.
No, I think that's a really good point. You just literally just talked about it, because it's so what it's, I feel like, as is mentioned, that so many times we usually talk to people who are outside of our, area. It's like they don't have the same skill set, or they don't have the same analytical mindset to decipher our story so they could understand what we're trying to tell. So right. How we can actually figure it out, that how we can, just break it down at the granular level so that people would get the idea. So you can just, maybe we have to put some words, or maybe we have to drive, or maybe we have to just, come up with a different analogy to narrate our story so even a layman could understand. So that's also the biggest, I think, one of the bigger aspects of data scientists, or even an actual skill sets as well, that communication, and how you can communicate to that other people from other areas. And that kind of brings me to the kind of our next topic is, so given that, we're talking about so what, and I know that, the actuaries and data scientists, they're responsible to do some product assumption, product review in the insurance world. Data scientists also perform similar kind of market research or analysis in the other industries as well. So now I'm just going to talk about a little technical here. So do you think that there's the concept called like hypothesis testing, or even A/B testing would help us to kind of like alleviate this issue a little bit, like because that the hypothesis would tell us, okay, we are doing it for that, if whether we are rejecting null hypothesis or not. So we at least will be able to construct some sort of a hypothesis or some outcome based on those testing. So do you think this sort of techniques would help an actuary or data scientist to kind of like answer to that so what question?
I haven't heard that proposal before, but I like it. I like the idea of taking that analytical mindset and that analytical process, whether it's a hypothesis test, it's an A/B test, and applying it to the data analysis that we are working on. I think that's a good way to build some of that mental expansion beyond just the what are you doing and trying to get some of that impact. So, an example might be if you're doing some A/B testing on categorizing potential clients, and I'm going to come back to insurance clients again, because we've talked about this before. You've got a whole portfolio of clients. Your A/B could be, do we get more profit if we have 2 groups of clients, or do we get more profit if we have 3 groups of clients, right? And so the A/B testing in that way, the data scientist might have it in the perspective of their mind of 2 groups gets me a tighter fit, right? And then 3 groups. And so I want to use the 2-group methodology. However, if you can introduce that next level of, well, are we really just looking for a tighter fit of data, or are we looking for more profit for the business? Sure, it might be a little less tight of a fit. And so it's not a data science question anymore, but the B option provides us more of the answer that we are really looking for. So I think that's an interesting way of thinking about it. I hadn't thought of framing it that way, but I like that. That's good.
Yeah, the reason actually I'm kind of like, because I was reading some article on this so what thing and see how the people from other industry usually kind of like address this kind of question. And especially if you talk about Facebook or even Netflix or those, product marketing company, I mean, in their sales team, they usually perform, A/B testing in order to find out whether an ad is underperforming or overperforming. Like, for example, I know Facebook usually just run some testing on their new ads on the platform, and they just kind of keep it running for like 7 days. They capture all the metrics and they perform A/B testing based on the metrics, and that's kind of the result, kind of their determining factor whether they're gonna implement that new ad or they're gonna just keep it as is. So that's right. Kind of like the main, I guess, driving factor why I thought maybe a hypothesis or an A/B testing could address that question a little bit, but I feel like it's more of like it's like we have to basically like come up with the performance metrics from the test A/B testing, and we have to couple it with our subject matter expertise. Because at the end, I feel like you're an actuary. When a data scientist will work in insurance world, they always need to kind of like team up with the actuary to get that additional subject matter. So obviously, the data scientists, even if their A/B testing would provide them a good result, even if that it is less than p-value, it's significant. Still, I feel like an actuary and data scientist needs to work with an insurance actuary to understand whether that particular hypothesis would have any impact on the insurance. And that's where actually that I would say the subject matter expertise come into picture. And as you stated, kind of like at the beginning of this call, that actuary and data scientists could work together as they can actually contribute together to a common goal of making a better product review or addressing this very tangible question of so what.
Yeah, absolutely. Yeah, I think that this is, that's a great introduction and a great way to talk about something that is pretty important to me. And, you mentioned, figuring out that hypothesis testing. I think this is a good reminder to all actuaries, data scientists, all quantitative professionals to restrain your excitement at jumping into solving a problem before you really know what the real problem is. So there's a lot of pride and a lot of skill in many professionals who are really good at what they do. And they hear a statement by somebody else, maybe it's the marketing director or maybe it's the finance officer, and they immediately go to, oh, I can do that because I have this data set and I have this dashboard and I have that other thing. And so they immediately jump in and try to solve the problem with data science or with an actuarial analysis. However, I think that sometimes, and probably more often than not, leads to the problems that we come back to when we end up with a lot of cyclicality, we end up with a lot of revision, we end up with a lot of impractical output because we didn't do enough understanding at the front end of what was that audience really trying to understand. And that's really what the so what is about, right? It's you can have all the data models that you want, and you get to the figuring out the so what and the importance by asking a lot of questions early and upfront and often, and being willing to say, you know, I'm not sure yet that we know what the right problem is that we're trying to solve. Correct. And then asking some more questions and more probing questions, because it's kind of like the iceberg. You might think that the problem that you're trying to solve is just that little bit that you can see above the top surface. But what's really deeper is maybe you have poor data governance practices. Maybe you have no data governance practices at all. Maybe you have poor software engineering. Maybe you have legacy systems, right? Maybe you have something else that all of these other problems are sort of cosmetic and they're trying to get at the surface level. But what you really need to do is understand that deeper problem and that deeper challenge. And when you do, you know, then you'll be able to provide a lot more value with your analysis because you know why the so what is happening. You know, it speaks to, you know, a little bit of humility that I think I know actuaries need to have some, because we love to jump in and just start solving the problem, and maybe be not quite so anxious.
Take a step back to try to understand why I'm doing this, you know, like, and what kind of effect it's going to make on the business. Right. I mean, that's a really good thing, because so many times we literally bog down with, like, you know, meeting the project timeline, or maybe just building a kind of a proof of concept at the beginning of the phase so we can make our customers or our senior executives happy. But sometimes down the line, we miss the big picture, because so many times a project didn't get ended properly because we don't understand that why we have started that in the first place. So I think that's a really great point, because as an analyst, I think it's not about like only just using different tools to come up with building a dashboard or come up with the story. It's also like analyzing the reasoning that behind this particular, you know, the project or the story stuff. So I mean, that's a really good point, and I'm pretty sure my viewers would get a lot of insights by, you know, listening to both of us, because that's one of the biggest factors. And so many times data scientists, they really kind of like think about, okay, I got to be expert in R or Python, or I got to learn SQL, I got to learn how to, you know, code algorithm. But why you are doing this, you know, like why, if you you know, think in that way, if you think about, like, you know, building a predictive model, then what kind of business drivers it will fulfill, what kind of business driver behind that predictive model. It's not about just, you know, just projecting something or other than that, but what next, you know, like, you know, once we put it in it's obviously it's a very I guess intriguing, I guess, question, and like a lot of people usually don't get to know about that, but I think hopefully after listening to this discussion, hopefully they will get us some idea, and they might be, next time when a data scientist and an actuary would start taking over a project, they would take a step back and think about why they're doing this work, and, you know, what would be the kind of a long-term goal of this particular, of their models or whatever they're trying to build in their work.
That need to understand the big picture is I think very critical. And unfortunately, it's not something that gets talked about a lot. As you said, a lot of times we talk about the tool, and we talk about a metric, and we talk about a number, but we don't talk about where it's going to go after that.
Correct. So now, since we're talking about this so what and something, how did idea first came into your head? Is it something like you are working on a project and you kind of realize that you just kind of like just fulfill the need of like you just, you know, deliver the project, but you kind of miss the bigger picture. You kind of didn't get that. How did the idea first, you know, came to you? You know, like, I mean,
well, I don't know if I have any specific. Sorry for talking over you for just a moment. I don't know if I have any specific eureka moment when I realized, oh, that's the big problem and challenge. It's something that sort of has evolved throughout my career. One of the reasons I think I evolved some of that mindset is because I was too busy with doing all of the different tasks. And one of the things that I did, and don't tell my former employers this, but I would just stop doing work that I didn't think was important and seeing if anybody like noticed. And if nobody noticed, then it wasn't very important. And doing that showed me that there was a lot of emphasis on task and not much emphasis on importance or output. And the traditional saying is that all models are wrong and some models are useful. The whole point of doing the work that we're doing is to be useful, not to just be right. And I've had several conversations with talking with other actuaries, with software developers, with data scientists, that yes, we can do that thing, but so what about it, right? And it's I can't say that there's any one point where I realized that this was a thing that was happening within the actuarial profession, but it is something that has evolved over time, and it is something that I still see. And in fact, when I talk with people like yourself or other connections on LinkedIn, this is not an isolated problem to just actuaries and data scientists. It's all business analysts. In fact, it's true of marketing people, and it's true of underwriting, and it's true of social scientists. Everybody tends to be very focused on the thing that they're doing, and it's very hard to step back and look at the why that they're doing that.
Yeah, I feel like, it's so many cases, the thing would happen, like somebody, a data scientist or an actuary, they build a model, but sometimes I feel like the model is more of like, it's an intrinsic nature for specific to that project. I mean, that model, you don't know if it could be repeatable or, something like that. And if we go back to that, all the models we use, most of them are like based on either a linear regression or a logistic regression, where somebody who developed the linear regression in the first place had that idea, the bigger picture, that formula, that technique would be, like repeatable for like 500 years or years down the line. Right. So, but yeah, I mean, we kind of like miss the picture. Like we don't, sometimes I feel like data scientists tend to just follow the pattern, they try to find the pattern, but sometimes they feel like, they don't understand, or sometimes they miss that fact that, why their work should be, leveraged in future, how their work would be leveraged in future. I mean, their work should not be like, bound to one specific project. I think that's where I think when we answer that, when you get that answer that, okay, this is where my model can be leveraged in other industry, or maybe in other work within insurance industry, or maybe other areas. So once we find that answer, I think then I guess maybe a data scientist will be able to address that question, maybe able to think in the broader spectrum of their work or the contribution they're trying to put place in the community. So yeah, so I mean, while talking about it, one thing I kind of like, I was very curious that as you mentioned that there'll be a scenario when an actuary could team up with a data scientist and they can work together. So I know from a data science perspective, they lack the subject matter expertise. They are not as efficient in knowing business knowledge, insurance business knowledge like an actuary. So in a hypothetical world, if you think an actuary and data scientist will work together, how do you define their roles? Is it something there'll be a segregation of duties or something? This is more of like something. I mean, the common goal is like they will work together to address that so what question.
Sure.
In that scenario, do you think they should have a segregation of duties among themselves, or they can just work together to achieve that common goal? I mean, it's just a hypothetical question,
Yeah, I think in every relationship, in every partnership, there's going to be a separation of duties, so there's going to be an overlap in collaboration points. For example, an actuary working with a data scientist, one of the projects that we recently worked on was looking at some competitiveness for prices of annuities. Mm-hmm. So we have competitive price analysis for term life products, and in that domain, the data scientist says, here's a price that's 800, here's a price that's 799, that's a better price, right? In the domain of annuities, if you get paid a payment every month of 800 and you have another one that's 799, well, that relationship is inverted, right? So it takes the actuary to know that it's important to have a higher payout on on an annuity and a lower price on a life insurance premium. So and one of the statements that came out during one of those conversations was the actuary said, it was so intuitively obvious to me that I didn't think it needed to be said, like that difference in which is better, like higher is better for annuities. So yes, there's going to be segregation of duties. There's going to be separation. There's also going to be a lot of collaboration. And this will again come back to the fact that I think both sides are going to need to define their terms early and try not to have too many assumptions, because assumptions are the ways that we create a lot of confusion. There really isn't any confusion. If you see a 2 and I see a 2, we can both agree that it's a 2. But if you see a thing and I see a thing, and we both have different assumptions about what thing means, that's where the confusion is going to come from. So yes, actuaries and data scientists, when they're working together, they're going to have different roles. And again, this is going to sort of flex on the project. How much data does the actuary analyze and how much business does the data scientist reflect within their model? Those are going to be kind of flexible at times. I think the more important part is going to be having a good collaborative relationship, as well as having good understanding of common terms. So if you can get away from those things that are just in your head because they're assumptions, because they're so deeply ingrained into the way that you work, you just automatically know it, and you don't think it needs to be said. If you say it, well, the other person might already know that, but it's good to confirm that. And so then, the other side, if they had a different perspective before, they should be saying their perspective, so you come to an agreement rather than having conflict.
No, obviously, definitely, again, the old thing, like being flexible and being receptive to ideas would actually bridge the gap. So I guess in that sense, from statistical point of view, an actuary might know a way more than a data scientist. But maybe from the programming language standpoint, maybe a data scientist knows a little bit more than actuary. So that's how they actually can collaborate together and contribute to each other's effort, right? So it was a pleasure talking to you, Stephen. Anything else would you like to mention on this very so what topic to my viewers? Because this is a great and a very interesting topic, something we could talk for hours, but we do have some limited time for today's session. But I think I guess I just want to close it with some of your tips or feedback which you'd like to share with the viewers on this very interesting topic.
Yeah, I guess my point would be to recognize that, and this is going to sound very trite and it's going to sound very, very overused, but remember that your education and your evolution as a professional is a process. It's not a one-time thing. You can't just automatically tell yourself, okay, tomorrow I'm going to be more focused on the end result and the output. You have to take gradual. Yes, you have to retrain your brain, as you said, over and over and over again. Whether you're talking about communication skills, whether you're talking about collaboration skills, whether you're talking about negotiation skills, whether you're talking about understanding the problem skills, all of those are incremental developments. You're never going to get to where you really want to be or think that you've arrived, because you can always make it better. And yet that shouldn't stop you from trying to work on it. And it should not, you should not assume that you're always going to be bad at that skill, right? Like any other skill, they can be developed if you have some time and if you have some dedication. And if you have some feedback on that too. That's the one important part that I think several people sometimes forget. They try to do something, but they do it without feedback, and then they never really improve anything. So though, take some time, dedicate to some work, get some feedback, and you can improve those skills, whether they are negotiation, whether they are collaboration, communication, or seeing that big picture, seeing that so what importance.
Thank you, Stephen. And those are a really very informative and very good advice, because I'm pretty sure that a lot of junior data scientists and people who are getting into the data science field would get a lot of information or some valuable advice from this discussion. So if you guys want to follow Stephen Mathys on LinkedIn, I think he has a very good LinkedIn profile and is very active on there. So please keep following him to get to know more about what's going on in the actual science, or he'll be interested to engage in a discussion with other data scientists as well. So thanks, Stephen. Thanks for joining my talk today. And I appreciate your time and generosity. I look forward to chatting with you on LinkedIn or in other forums. Thank you.
Very well. Nice to speak with you, Sam. Have a great day.
Yeah. Thanks to my viewers, and keep following and subscribing to Data Science with Sam.